Alright, so we're going to do another problem. This next problem is going to be very similar to the previous problem. I watched my previous problem. It was my first video. I hope you guys enjoyed it. But I realized that there's like a glare right here. I'm doing this in my room. I don't have blinds in my room, so I apologize for the glare. But like I said, all my notes are going to be uploaded on there. They're fully worked out, so you could always take a look if like that glare got in the way or something. Okay, so this problem is number 33. It's also on page 250. It says the top of a ladder slides down a vertical wall at a rate of 0.15 meters per second. At the moment when the bottom of the ladder is 3 meters from the wall, it slides away at a rate of 0.2 meters per second. How long is the ladder? Okay. So let's go ahead, draw a picture. A lot of these problems, if they don't give you a picture, draw the picture. On the previous problem, they did give you a picture with the boat. I mean, it actually had a boat and a dock and a rope. You had to draw your own triangle. This one, so it says the top of a ladder slides down a vertical wall. So I've got my vertical wall, and of course, it's got the ground somewhere. And then I've got a ladder right there, okay? You could already see what shape we're going to have. We've got a right triangle right there. Okay, so we could label this distance x, this distance right here can be y, and then this distance right here, oh, that's a really bad z. Let's see. That distance right there, z. Now, what this problem is saying is the ladder is sliding down this wall. Okay, if the ladder is sliding down the wall, it's going that direction, it's moving in the y direction. This is dy dt. Now, as it slides down the wall, goes down this x distance, goes like that. It slides against the floor. Okay, we're assuming here it's perfectly sliding against the wall and the floor. Reality, that might not happen. But as it slides down, this ladder is going to get pushed that way. So this is going to be dx dt. Now, we can put a dz dt. If you notice how these problems are going to work, the right triangle problems using the Pythagorean theorem all pretty much are the same. So this is going to be a dz dt over here. Now we know what we're doing. We've got our givens. So let's go ahead and write our givens on here. Now, the x distance. Let's see. They want to... Where is it? At the moment when the bottom of the ladder is 3 meters away from the wall. So from here to here is 3 meters. They say that it slides away, so it's sliding away is this x rate is 0.2 meters per second. Now, they also tell us how fast this ladder is falling down. It is falling down at a rate of 0.15 meters per second. Now, let's look at what we're trying to find. They asked us, how long is the ladder? Meaning that we have to find this z distance right here. How long is the ladder? Now, one way we could do that is if we have this x distance, we have this y distance, we could use the Pythagorean theorem to solve for z. And that's actually what we're going to want to do. But now let's think about it. The ladder is some z, whatever it may be. Let's just say it's like 6, okay? As this ladder falls down, does the ladder change size? If a ladder were to fall down, should it change size? As this marker, if it was standing up against my eraser here, as it falls down, does it change size? No, it does not. So the rate of change of z, dz dt, is going to be 0. So we've got all our givens here. We don't know what y is, okay? So that should give us a hint of what we need to find, because I already told you, we could find z if we know x and y. But we don't know y, so that's what we need to find. Overall, we need to find z, but z will disappear in our equation. And you'll see, I'll point it out. Again, let's write our givens over here. We've got x is equal to 3 meters. We've got dx dt is equal to 0.2 meters per second. We've got dy dt is equal to 0.15 meters per second. And those are all of our knowns, all of our givens. So I'm going to erase this, and this is just so we can see what's going on. The equation that relates to this problem is Pythagorean theorem. So we've got x squared plus y squared is equal to z squared. Now let's implicit differentiate. You get 2x dx plus 2y dy is equal to 2z dz. And if you notice, again, the 2's are going to cancel out. Gone, gone, gone. Not only that, I'm going to divide by dt in this same step. So now I'm going to rewrite the resulting equation. Ooh, wrong color marker. I want black. There we go. We've got x dx dt plus y dy dt is equal to 0. So you could see from here, we can solve for y. We got to move this term over to the other side, and then we got to divide by this term. So let's go ahead and do that. So I'm going to minus x dx dt minus x dx dt. And then over here, I've got y dy dt is equal to negative x dx dt. So now we just have one more step. We want to solve for y. We just got to divide by dy dt. So divide by dy dt, divide by dy dt. Okay, so I'm going to keep that one over there since that's our last step. Erase this, these pieces over here so we can get our final expression for y. So we've got y is equal to negative x times dx dt divided by dy dt, which is equal to negative x. So negative, our x here is 3. dx dt. dx dt is 0.2 divided by dy dt. dy dt is 0.5 or 1.5. Let's fix that. There we go. And this is going to equal to negative 4. Oh, I messed up somewhere. I just realized it's a distance, isn't it? It should not be negative. dy dt is going downwards. So it actually should have been a negative velocity because we're defining the y direction to be upwards. So that should have a negative, making this a positive. Y is in meters. I apologize for that. Okay, so now that we have y is equal to 4 meters. Let's see, we know x is equal to 3 meters. We want to know how long the ladder is. Well, now we just go back to our Pythagorean theorem. X squared plus y squared is equal to z squared to just get z, you're going to have to square root both sides. So you got the square root of x squared plus y squared is equal to z. And upon plugging 4 and plugging 3 into here, you're going to get z is equal to 5 meters. And there is your answer.